All right, welcome to the second part of this video in which we're going to go through another example. The question before us says, find a sequence of transformations that takes this to this. All right, let's begin by doing it by inspection. Remember, when you're doing this by inspection, the first step has to be to factorize inside the brackets. So that means instead of writing 3x minus 6, I'm going to take 3 out. And that's going to leave me with x minus 2 in here. And then I'm going to have a plus 4. Now what I'm going to do is I'm going to read off the transformations which are taking place. The first one I'll read off is this 2. Remember, I start with my dilations, so that's why I'm starting with this 2. So dilation of a factor of 2 from the x-axis. Then I'm going to read off my other dilation which is occurring here, which is this 3. Now this is where people get tripped up. This is going to be and by a factor of 1 on 3. You have to take the reciprocal of it, and it's from the y-axis, from the y-axis. After we have read off the dilations, you then read off the reflections, which none are occurring here. I know none are occurring here because I don't have a negative in front of the entire function, nor a negative in front of the x. So that means I move on to my translations, and I can see that I have a translation here, and I have a translation here. So I'm going to write them down. I'm going to say I have a translation. Oh, make sure, I nearly made a mistake there. You have to write then. You have to make sure that there's a sequence to it. So if you don't have words like then, or I don't know, then, after that, something like that, something that gives a sequence to it, you'll get it wrong. So make sure you got those words like then. Then, what was I saying? Then a translation of 2 units in the, now, we've got to be careful here because there's a negative in the positive x direction and 4 units in the positive y direction. Man, it takes forever to write. Okay, there we go. All right, so as you can see there, the way I approached this was I began by reading off my dilations, dilation of a factor of 2 from the x, as you can see there, and by a factor of 1/3 from the y-axis, as you can see there. Then I looked for reflections, there were none, so then I looked for translations. There was a translation here, a translation of 2 units in the positive x direction, then I had a plus 4, and 4 units in the positive y direction. Perfect, and we're done. The other way to approach this is to do it by the method, which is going to take some time. But let's go through it. So if we were to do this by the method, remember the way I like to begin these is by saying we start with a point x, y. We're then going to a new point x dash, y dash. We know that our original point lies on the graph. Now what was it again? 1 on x. Y is equal to 1 on x, and it's going to the graph. Y is equal to 2 over 3x minus 6 plus 4. I put my dashes here. I now rearrange the right hand side, which is going to leave me with y dash minus 4. So I'm going to subtract 4 from both sides. Then I'm going to divide by 2. So as you can see, I can do that in one step. Then what I do is I equate. So I equate this y with all of this here, and then I equate this x with all of this here. So that means what I'm going to end up with now is y is equal to y dash minus 4 over 2, and x is equal to 3x dash minus 6. Then after I've done that, I now rearrange to find y dash, so I'm going to get 2y plus 4 is equal to y dash. And then, so I'm going to write it like this, y dash is equal to 2y plus 4. So I just wrote it left to right because I'm strange that way. And then I'm going to go x plus 6 divided by 3 is equal to x dash. So x dash is equal to x plus 6 over 3. And as you can see, these are the all-important things we need. This and this. And then from these, we can now read off the sequence of transformations. And I just, for completeness sake, we start here, and I've gone to my new point. And now I know what that new point is. I know that x dash is going to be, now, instead of writing it like this, I'm just going to break it up into x over 3 plus, now 6 over 3 is 2, and then this will stay the same. Then I read off my transformations from this right here. So I begin with my dilations. Let's start with this 2. This 2 is telling me what? That I have a dilation by a factor of 2 from the x-axis, and I have another dilation here, which is this one right here. This is telling me that I have a dilation of a third from the y-axis, dilation by a factor of 1/3 from the y-axis. I don't have any reflections, so then I move on to my translations. My translations are the easiest to read. I've got this +2, which is telling me I'm moving x units in the positive x directions. Sorry, I'm moving 2 units in the positive x direction. Remember the word then. Then a translation of 2 units in the positive x direction, and then I read off the other one, +4 here, and 4 units in the, wait for it, positive y direction. And we are done. So as you can see, I followed the sequence correctly. I first read off my dilations, then I read off my translations. And as you can see by the method, the way I'm doing it is I'm reading off the x dash y dash 1. And I'm done. That's how you would approach it. Look at all that work. There's a lot of work there. Hopefully all that made sense in how we did it, and hopefully you're able to get the right answer. As you can see, this is the same as what we did here. So there's a question of what do you find the most convenient way? Most likely you'll say, well, this is clearly easier, but there are some advantages to this as well. All right, we'll pause it here before we go into our next part. Hopefully you found this useful.